So hello everyone, welcome to Dr. MDS Academy. Here in this animation I am going to show you inversion of single slider crankchain. Mainly we are having 5 different types in this inversion of single slider crankchain. The first one is the pendulum pump, also known as a bull engine. Okay, one by one we are going to look in the animations, how they function. Second is the oscillating cylinder engine, and third is the rotary internal combustion engine. Okay, and then the fourth one is the crank and slotted lever quick return mechanism. Okay, and the last is also sometimes we consider this in the single slider crankchain known as Whitworth quick return mechanism. This is less common. Okay, so one by one we are going to see the motions how takes place in the different. See the first one. Okay, so just pause all those, make the RPM 0 in all the cases. Okay, all right. Now in the pendulum, see the pendulum pump are also known as bull engine. See the crank. Now I have set the RPM 0, means it is stationary. See the crank length I am changing. This blue line is the crank length. Currently at 50 right now. Okay, you can increase it the okay connecting rod at the same time this okay, make it off. Connecting rod. See the green one is the connecting rod length. Okay, you can change it. Okay, now we are going to see the how the motion takes place or how the construction line is making by this pendulum pump. Just make it on trace. Okay, see the how the construction line. Okay, this mechanism is making. Okay, make the RPM little higher. Okay, so at the top you will find a piston. Okay, you had seen in the here in the pendulum case. See here, we are having a piston here. Okay, this piston. Okay, so this is upper side. Now in the line diagram in the notes it is given in the bottom side, but the mechanism remains same. Okay, so just change the crank length. See, make the RPM little higher. See the circular motion path is making by this pendulum. Okay, this is the C is the what? C is our piston doing up and down reciprocating motion it is doing. See here how the path is being okay, made. Crank length I am increasing the crank length. See, decreasing the crank length. Now connecting rod I am increasing, going little out of focus. Okay, so this is how the pendulum pump works. Okay, make it pause. Okay, and now I am going to discuss oscillating cylinder engine. This case. Okay, see here, crank length. See, trace I am activating. See the crank, make the RPM little smaller. Okay, see what is the crank? This blue line is the our link. Okay, this length I am increasing, make it 0. So this blue line length I am increasing or decreasing. Okay, decreasing the blue line crank length, increasing the crank length. Connecting rod is which one? The green one, this green one. Okay, crank, this one is the crank. Okay, okay, RPM I have just started motion, doing motion in oscillating cylinder. So now match this oscillating cylinder animation with this diagram. Okay, is it matching now? The trace or the path motion taking place by the oscillating cylinder is like this. Okay, make the RPM little higher. Okay, connecting rod I am increasing length. Okay, just decreasing the crank length. Okay, see how the motion is it is doing. Okay, so you can find a piston here now. Same piston you will find here also. Here piston, this piston P is moving up like this. See how the motion is, this mechanism is making. Okay, connecting rod, crank length I am decreasing, RPM I am decreasing. See, okay, that's over. Now the RPM I am stopping. Now I am going to discuss rotary IC engine, internal combustion. See, you will find number of cylinder pistons around 1, 2, 4, 5, 6, 7 like this. Okay. Similarly, you will finding here also. Okay. Now RPM as you will increase. So this is the trace mark or path. Okay. The radius. What is the radius here? See. What is the radius here? See the radius. Radius of this one. Okay. I am varying. Okay. Path RPM I have supplied. Okay, just start doing. Okay, the similar you will be finding in the line diagram also in the, okay, here also. Okay, now the decrease the arc radius of the crank. Okay, you will find the RPM I have increased. Okay, just decrease the RPM and see little carefully. See, these are all around. We are having a number of cylinder pistons. Okay, similar to here, cylinder piston arrangements. Okay, this whole mechanism rotates. Okay, crank, this crank length, I am, okay, it is generally fixed at here. I am decreasing the radius, okay, of the crank. Now increasing the crank and increasing the RPM. See how the motion is taking place, okay, in case of rotary IC. Okay, so this was about the rotary IC engine. Make it pause here. Now last I am going to show you, we can understand how the crank and slotted lever, which is generally used in the turn mechanism, and you will find here. See what is crank here. This is the crank. Okay, little. Okay, just make it stop here. Okay, okay. Now crank is what? This blue line A from air. This one is our crank. Okay, you can play with that and you can change the length of this crank length. Okay, similarly stroke length is what? This D to C. This is our stroke length. Similarly you will find here also. This is our crank and this is our slot length. Okay, similarly you will find here also slot length. Okay, here is the ram. Okay, similarly you will find here ram also. Okay, moving horizontal here. Okay, when it is moving right means cutting is to left, means return is to. Okay, RPM, just make the RPM active the trace. Okay, this is the construction motion line, okay, made by the crank and slotted lever tube return mechanism. Okay, just change the length. Okay, in the slot length, in the slot length. Okay, so this was all about the inversion of single slider crank chain. Okay, so I hope it is clear. Okay, so this was the pendulum pump case. Okay, another case was the oscillating cylinder engine. Okay, cylinder engine. Third was the rotary internal combustion engine, also known as down uh, mechanism. Fourth one is the crank and slotted lever tube return mechanism. Okay, so Thank you all.